All right, hello everyone. My name is Mildred, and this is our second live class on Ginger templating and on building our class project. This class is for batch A and B, as both of you have now transitioned into part 3 of the course, where we do our class project. We're building an STI data collection system. And for those who will move on to the data analysis course, we are going to look at how we collect this data, use it for reporting. Last live class that we had 2 weeks ago, we looked at Ginger templates. We looked at how to create HTML templates. We have some prerequisite videos for building HTML forms. I think for batch A, you must have looked at those videos, and for those coming from course 1, you must have done HTML forms and some CSS and JavaScript. We're going to use that here. It is not required that you understand HTML, CSS, or JavaScript, as I will provide the template. But it is important that you are able to complete your assignment using the knowledge of forms that we will provide for you based on some prerequisite videos. I think from week 22 or thereabouts, you'll be looking at HTML forms. I have created some forms in advance, and we discussed in the last live class that Flask wants to see a folder called templates, written in the same capitalization, plural, templates. And it looks for HTML or static files, HTML files in this template directory. So every time you want to have an HTML file, you want to put it in a directory named template. CSS and JavaScript should be placed in a folder called static. When you have these two, there are ways you can modify and change these things and write extra code, but for beginners, it's better you stick with having a templates directory for all of your front-end code. When I say front-end, I mean just HTML, and static, which is still front-end for your CSS and your JavaScript files. I've also created here a models directory, and this is just going to hold the different classes for our database table creation. We looked at how to connect. We used Context Manager in the last live class, and we looked at how to connect to the database and create a table just for trial. We're not going to do that here. We're going to create our table using models, and we're going to create our database before we start doing that. We also looked at SQL Alchemy. We installed SQL Alchemy, and we say this is the method of choice for this course. We looked in week 21, 22, 23 at a different way of connecting to the database, but we want to use object relational mapping, and we use SQL Alchemy to do that. And when we use object relational mapping, it's just trying to use classes to map different methods. We're going to see how that is going to be done. Okay, and because we use declarative mapping, and declarative mapping is just a way that modern SQL or modern SQL Alchemy constructs the mapping of our classes or the different methods to a database column and things like that. A database table column, sorry. So we created this template directory. I have my app file outside the directory, and I have my templates that has an about page, a base file. We looked at in the last live class that this base file is just going to be a file that holds common codes that all other HTML pages will inherit from. And we looked at how to create blocks, how to write expressions and statements with Ginger templates. We use open curly brace and a %sign. And then we give a block a name. I like to give it the name. So you can just be block, or you put block head and then you end block head. This is a placeholder for the inheriting template, or for the child template to be able to insert whatever they want here. And these are the base codes that we want all pages to have. We want the meta, viewport, and description, and we want the character set also to be defined at the base. We also want the common style sheets to also apply here. Now, we did not look at URL4, but URL4 is something that is important. It's like a helper function that we have, and what it does is that we can dynamically prepare our URL for a function, and this will just make us avoid changing our URL in the application. For instance, here we have a /. Instead of putting the / here in the base, if we use URL4 and then we specify the name of the function, then to just look for the URL for that function. So even if we change the URL in the future, we're just referring to the function and it gets the URL for the function. That is one use. So you will see URL4 in many stuff, but there are different ways to do the same thing. I like to do it like this. So when I say URL4, I specify the directory, which I know is static, and then the file name in that static directory is style.css to put the style sheet, and I also did that here. This is one way of using it. Another way of using it is when we get to our different forms here and we decide to use URL4 register client, which means I'm going to create a function called register client, and the route decorator URL is what is going to look for as the action page for this, but we're going to look at that step by step. So we have a base file, and we want this base file to be the base for all of the root files. So the files before authentication, things like the about page, we want it to inherit from the base file. Insert a new maybe meta description, since the description of the about page is different. We want to also give it a space to put the title and also then the block for the content to have a different content for this page. We also did the same thing for the overview page, where we define the content within the content block, and then we define whatever we want in the head block like this. Now we created a login page, and I did this off class because we don't want to create that. The login page that I created here is an HTML template. I use Ginger templating. It first of all inherits from the base file, and then we use the block head here to be able to insert what we want for the head in addition to what the base produces like this. So when you are using blocks, you make sure that the base file has that block placeholder for the child file to be able to use that block to insert new tags there. We also have new style sheets for this. We have a style sheet called login.css we want to add, and we want to actually add the font awesome to put different fonts and icons on the page. This is going to be in addition to what the base also provides, the style sheets the base provides. So because we have block style sheets, we are able to insert new style sheets on the child file like that. Does everybody understand?
Yes.
Okay. So I'll make the repository for this available so you can have access to the code, but I'll only do that after a particular assignment that deals with this is completed, so that you guys will try hard to do it yourself. All right. So when we get to the content block of any child template, we want to now define all of our, if it's the form we are creating, the contents, all of the HTML tags, we come between the start and end content block for every page, since the content of each page differs from the other. So the basic idea is that when you use a base file, you put placeholders for where you want to insert unique content on the child template. And so everywhere you want a unique footer there, you put a footer block, and the child template can use that to insert new footer elements for that page. And the style sheets, they can insert more style sheets in addition to the ones here, and also put a title and also add more meta data on the page. I have created an STI form, register form, a profile form, overview, login, index, home base. Now I created this home base to be another base file that is going to be inherited from pages that are protected. When I say protected, it means that these pages should only be displayed when the user is logged in. And so this is going to be the home page for those pages that are displayed only after successful login by a user. Then we'll have hepatitis and congenital syphilis. And before we go further, let us look at the forms that we are going to be working with. Now in your course resource, we have these forms already uploaded, and you should download these forms, as this is what we'll be working with for part 3 and for our class project. And what we want to do is to collect data for chlamydia and gonorrhea, collect data for syphilis, both for the infant and for the mother, and want to collect data for hepatitis B infected pregnant women. Now, these are forms I downloaded off the internet for us to use this as an example to plan a model. Most of the time, when you have customers, you get business requirements. Half of the time, you need to research your business requirements and have some domain knowledge in what you're about to do. As most of the time, the customers do not really know completely what they need. They have an idea of what they want. You expand on what they want to give them an MVP, and they begin to take you in directions that you need to be, because now they have better insights based on your knowledge. All right. So for us to design this form, we want to look at the different fields that are to be collected across all the forms. That's the first stage of planning. Now, you don't want to collect the same information twice. And so when the same information exists in two forms, you want to just collect that information once and record them once. So one way of planning, again, is your logical reasoning. The first form for the STI case reporting for chlamydia and gonorrhea collects the name, the date of birth, the gender. The next form for congenital syphilis collects the same information of the person. And so you want to collect this information once. And so when you are jotting down or drawing your directory structures or your form fields or writing your business requirements, or you're trying to write your SRS document, you want to take note of the fields that should only be mentioned once. And one thing I like to do is to plan my model so that I look at these forms. I say, I want to have anybody.
What's happened? What is the problem?
Anybody? Okay. So please keep your mics turned off so that you don't interrupt the class. When we think about this critically, we can decide to say we want to put all demographic information in one table and then have a unique identifier for each client that we use for other tables that just is going to be like a foreign key. So whenever we want to see the name of a particular information, that foreign key links to a base table or a parent table that holds the demographic information. You can plan it. That's one way of planning it, using foreign keys so you don't repeat information across tables. Another way you can think about this is to say which information are sensitive. We want to put all sensitive information in a particular table. Maybe we want to encrypt the data going there, or we want to encrypt the data address. Whatever it is that you plan to do, you want to think about it first. Think about security, think about what the data is used for, the frequency of retrieval, the integrity. Are these data linked? So you're collecting information for chlamydia, gonorrhea, hepatitis B. You have separate tables. How do you link these tables together to refer to one patient? Maybe you want to have just one table that's for demographic information that has a patient ID or hospital registration number, and only that number appears on the other forms where that identifies the client, and that number is a foreign key, and that particular number is linked to the parent table where you can get the complete demographic information. So I've gone through these forms. I know exactly what information that this form wants to collect. I've seen that it wants to collect some demographic information about the ethnicity, race, the sexual partner, also about the reason for exam diagnosis, the site of the test or screening, the treatment plan for both gonorrhea and chlamydia. It also has the partner management plan for those who have sexual partners and ends up being positive or screen test positive for any of the infections. Also for congenital syphilis, there are two parts to it, that of the mother and that of the infant. He also wants to collect demographic information. He wants to collect information about the pregnancy, about the ethnicity. He also wants to collect information about the infant, about the infection of the mother, when the mother screened, what test was done, what treatment was given, the outcome of the treatment for the mother, the test results for the child, the outcome of the treatment of the child, if the child had any treatment. You want to register if the child is alive or dead. You want to give a diagnosis or the classification of the congenital syphilis for that child. So there are different parts, different kind of information collected there. And also for the hepatitis B infected pregnant woman form, we have the same demographic information, laboratory results, and we have clinical information, like information about the OB, the hospital, or wherever the client goes for antenatal and all that. Now, this clinical information, laboratory information is common across forms. So you first of all identify what is common across the forms. And you might want to make this data that goes into a particular table. So looking at all of this, we now realize that we need an authentication. We need to allow the users to log in to be able to register this information or collect this data. We need to encrypt some of this information that goes to a database. So which means we always need a login register system. The registration is going to register a new user, and then the login is going to allow the user to log in or authenticate by their credentials into the system where they'll have access to other forms. We need to be able to save information that's entered into the form, to be able to retrieve this information for updates, and we also need to be able to put all of the forms for a particular client in one place using their unique identifier or their patient number or hospital number for retrieval. So now that we have an idea of what it is that we want to create, we'll go back to Visual Studio Code and then we'll start trying to make this happen. Now, based on those forms that we have seen, I have created in the template directory the kind of forms I want to collect information from. Now, this is not a front-end course, and so I did not go through the hurdle of creating forms live with you, as this will take a lot of time and waste our time. But we did this in last 2 weeks live class where we created a Ginger template. So you follow the same pattern and build your forms. You can also watch the videos for those in batch B. I think in the next 2 or 3 weeks, you will have the videos for, yeah?
I want to ask, all these HTMLs, are they all forms?
Yeah, they're all forms.
About base, congenital hepatitis, they are all forms, right?
Yeah, they're all forms, yeah.
So how do they link to each other?
So this is where we are going, this is where you need a prerequisite for the course, which is programming with HTML5, CSS3, and JavaScript. Now, in week 22, I think, you are supposed to, all the lessons for week 22, I think week 22 and week 23, a particular week, 2 particular weeks, you're going to learn HTML basics, CSS basics, and how to build forms. Now, this is not the front-end course, and we are not expected to teach you how to use HTML, but you are expected to watch the prerequisite videos and understand how to do this. Now, how the forms are linked, they are not linked. They're just forms on their own. You do the link using URL4, using the action attribute from the form tags, using your redirect, and using your render template. So when you use that, you call the form, and then the form is going to be displayed. The only link that they have is the inheritance of the base file. Now, when you put the common template in a base file, and every other template or every other HTML inherits the base file using this tag. Now, the video that we sent in your WhatsApp group this morning is the video you should understand before this, because we explained this in the last live class that we had, and we wanted you to refresh your knowledge on it before coming to this class. I don't know if I answered your question.
Yeah, I've done that.
Yes. So all of these are forms that you'll be expected to create at some point in the course. And if you don't create the forms, there's another way around it where you don't bother to create the form, but you look at the form uploaded in your resource and just create variable names in your PHP, in your Python, sorry. You create your variable names. When you get to your app file or whatever file processes it, the data coming from the user, and then send that data to the database. And the front-end developer will look at these variable names and use that as the value for the name attribute for the HTML form when that is built. So there are 2 ways we can do this. For the people who want to do the Ginger template and build the forms and create the backend code to send to the database, and there are people who will just deal with only backend and not bother about the form and building the form, since they have a form and they know the data that they want to collect from the forms. So we have looked at that. We want to look at how to create models. And when we talk about models, it's just, we want to have table that we store this information in. First of all, we want to have a database. So I will go to my phpMyAdmin. Let's go there. And I will try to create a database. And let's call this database STI data. You can change the collation and the character set to whatever you want. So I'll create this to be STI data. This is the database that I want to send, or I want to create all my tables in. And I'm going to be creating this thing as classes, and it's going to be, we call them models in Flask here. So in my models directory, I created a file called models, and we want to use this file. Now, previously, we also looked at how we use SQL Alchemy when we introduced Flask. We looked at how to create a basic route to different pages, but we want to use this object relational mapping as the abstraction layer between our web application and our database. We said that to start using SQL Alchemy, we installed it and also installed a database driver or a DB API to connect with MySQL. So the idea behind all of this is to create a code representation of the database, and we want to use classes and objects to do that. When we use SQL Alchemy, we have some methods that it comes with that we are going to use. So we are first of all going to do the import. When I say from SQL Alchemy, import integer, string, foreign key, date, time, form. These are the different functions from that SQL Alchemy library that I want to import, because I want to bind, or I want to map the different functions from the SQL Alchemy to the column names for my SQL. And so there are these imports that you have to do. Then from SQL Alchemy.orm, I want to import the methods that I need to use. I need to use mapped column. I used to use map and declarative base. Now I'll tell you what the declarative base is. Like when we use declarative mapping, it's just an approach that we use to, let's say we just use this approach to be able to subclass to a superclass. I don't know how best to explain this. I'm just trying to get the words out to explain this. So what I do is just know that there is a base class that inherits from the declarative base. This is standard. We don't have any definition in the body, so we put pass. Now we want to create a base model. And this base model we're creating, we want to put a particular decorator, and we want to define something that will apply to all tables that we're creating. We want all of the table name to be in lowercase, to be converted to lowercase. And we also want to use the declared attributes decorator there. When we create this base model and we create the base class that inherits from the declarative base, we now, I did this twice, I can delete this. We can now create classes that inherit from both the base and the declarative base. And these classes are going to be the tables. So when we create a class with a name, we inherit from both the base and declarative base. So what you want to take note of is the imports that you have to do. These are the standard imports that we will first of all use before we start creating classes that will be our database tables. We also have to have a base class that inherits from the declarative base. We also want to create a class that we call the base model, and what we are defining in the body of this class is just a function or a method that takes the table name, converts it to lowercase. We also apply the declared attributes decorator there. Then now is when we start doing things based on the business requirements that we have. So these imports are standard. You might want to learn this, you might want to save this because you'll use this like this, or there are different ways to do it, but you can just use this like this in any of your model creation before you start creating classes. Now, based on the forms that we looked at, we want to create a table that will store the user's information. That's like administrators, their username, their password, and information like that. We want to also have a table that will collect information about the screenings. So let's say, based on how these forms are, we want to have a dedicated table that screens for, maybe a dedicated table that we use for chlamydia and gonorrhea screening results. And then we want to have a particular table that deals with the treatments. We want to have a particular table that deals with, let's say, the sexual partner treatment of that particular client. We also want to have a different table that deals with, like when we get to the syphilis, like deals with the mother's information for congenital syphilis. Then a separate table that deals with the infant information for congenital syphilis. And then maybe we'll have a separate table for hepatitis B infected mothers. So the plan depends. There's no fixed way of doing this. The best thing you have to do is to make sure it keeps to the ACID properties, and then that you're not repeating information across table, and that you use foreign keys to link information rather than repeat stuff. So here, I can delete this and we can start writing, or I can just explain what I've written already. The first thing I did was to create a table called STI data, and in the app file, I have imported Flask, our basic import. We did the render template import, and what this is used for is just for us to call this method, and in the parentheses supply the name of the HTML file that we want to render. Request also is when we're collecting inputs from the form. So the users fill in a form, we're going to use this request method. Redirect also is what we will use to get a response. So if I want to redirect to something, this is what I use. URL for is what I just talked about, that we want to use to dynamically prepare a URL for a function. And so we don't need to be changing URL in the application, we just write the name of the function. Then session also, because we are doing login register, we need to have a session that stores this information if somebody is logged in, and then we use that information. Then from models, which is this directory, we import all. So this is the folder, this is the file. The file name is models. So we just say from models.models, we import everything means asterisk. We can import one after the other, and import user, import client profile, import whatever we've written here. So that's what we've done in the on the app file. Then we import hashlib, and I'm just trying to do some basic encryption of the sensitive information using this hashlib. So we import. So these are basic imports. You can also research. There are different ways of doing the same thing. There are different libraries and applications out there that you can use. You can even use Flask to do this, but I chose to use SQL Alchemy. Is a better ORM to use than using an ORM that is dedicated to a particular framework. SQL Alchemy can be used across framework. It can be used anywhere, even outside of Flask. You can use it with Django. You can use it with Fast API, anywhere. So we create an object of this, and then we already saw why we do app.secret key to protect our cookies and information. This should be secret and it should be placed somewhere else, maybe in your environment file. We are not looking at environment files in this course, it is for course 3, but I'm just letting you know that we are doing this in the basic form. This is not the production way of writing your code. The connection string, like we saw in the last live class, you specify the name of the database plus the dialect, the driver that we have. I'm using MySQL for this, and then a colon, you put supply your database user, the host, the password, the port, and the name of the database. And my database is STI data. My user root has no password, so I left it blank there. at localhost is the name of the host, so I can put the port here if I'm not using a default 3306 of my SQL port. But because I'm using all the defaults, I just shorten my connection string to just hold the name of the database management system I'm using, plus the driver or the dialects, the colon / the username, colon the password. I don't using the password, so I omitted that. At the host, then you can also put the port with the colon / the database name. If you refer to your lesson notes uploaded in your course resource, you'll see a breakdown of all of what you specify there. You have to specify this connection string in quotes. Now, these are variable names, and you can put whatever name you want here. I decided to put connection string as the name, and I wrote it here so that when I change this connection string, I don't have to change it everywhere. I just mention the name of the variable. So we do app.config SQL Alchemy database URI is to provide the connection string for this app to connect to that database. And then we also use the engine we also create a database, a variable called engine, and we use the create engine method to be able to provide the connection string that we have done. So this engine is what we will reference or that we will use whenever we want to execute any operation or any SQL query. We have stored this in a variable called engine. Now I'm going to explain what this means. For now, you don't have to know. Now, the methods you need to understand before you go forward is when we have create engine function, we have the different methods for this. When we use create engine, we can use the connect method along with it. We can use the execute method, the begin method, the dispose method, also even the driver method, table names, transaction. I wanted to research this create engine function and all the methods that it comes with that you can use with your connection. Now, when I put base.metadata.create all and in parentheses engine, what I just mean here is that because on my models, I created the base class that inherits from the declarative base. And I don't want to have to specify each class one after the other to create them. I wanted to create all of the tables that I have specified in all of the classes here all at once. And what that code simply means is run all of the classes there and create the table in the database that I'm connected to here. So what is standard that you must have in all of your at the top of all of your imports and all of your variable declaration is this. And when you have this, you replace your secret key with whatever secret key that has to be secret and known to only you. And then your connection string will be based on your database management system plus the driver or the dialect you are using. And then you specify your username, the host, the password, the name of the database. In that string, this is also standard. You specify your app.config and you say it equal to this. You can actually just copy this and put here if this is not a variable name. And then you create a variable. You can call it engine or whatever you want, but you make sure that you are using that to create engine, where you can also run the connect and the execute and the begin and the transaction commands or methods from here. Then when you have tables to be created, you want to make all of these tables to be created in the database all at once. We use one line of code, and I can put a link to another video on YouTube where we actually went deeper in this and we looked at how to create a table one after the other if you want to try that for testing. So this will prevent you from specifying the classes one after the other or importing the classes from the models one after the other. I just imported all and I created this. Now I will tell you again, this is not a production ready way of writing your code. We can't jump into production ready way of doing things because you will get confused and because you will get lost. So we're going step by step. Once you understand this, you'll be able to move higher to clean up your code to production standard. We also looked at how to create a route, and we use this route decorator at app.route, and in the parentheses of that route, we put the URL. Now, we already know how URL looks like. We put a / and the name of the URL. So like for the landing page, it's just a /. For the about page, / about. If our about URL is different, maybe it's news, it's / news. If we're using extensions, file extensions, .py, but we're not using extensions, Flask here doesn't use extension. So when you see applications like written in PHP and you see .php on your URL, it's because the extension was allowed to be displayed. Okay? So we have the different routes. We have said that we create the route decorator and the function that it binds to, so that when the index page is reached, we want it to run this function. And what we want this function to do is to render the template index.html that we've already created. So every time we hit the landing page of the application, we want to see an index page. What do we have on the index page? We just have some welcome information that tells us about the page. Okay? When we come to any route that has, let's say, login, we also specify the method getPost. Now, when we say login, there are two things we can do with the login: display a login form and fill the form and submit the form for you to authenticate and be redirected to your home page when you successfully log in. Now, we looked at different HTTP methods, and we say that when we use get method, it's mostly for things that are not secured. It can be bookmarks. You can't do like you are sending sensitive data over a get method. When we do post, is when you have things like password, credit card information. This cannot be bookmarked. It does not display in the URL. It sends this securely. So we use get to just retrieve a form, and we use post to send the data that we entered into the form to the processing page to be sent to the database. Does anyone have any question? Do you all understand?
No questions.
Okay.
Me too.
All right. So what we've done here is we've created templates and we're looking at the app file. Before we look at this, let's go to the models and now look at what we did with the models. I've said that I want to have different tables, and one of the things I want to do is to separate the tables so that we'll have things that are collecting similar information in one table. First of all, I want a user table, and I want the table name to be user. So when I use this table name magic method, I put equal to the name of the table that I want, which is user. Now I created a class called user. The convention and what I prefer to do is to write the class name to be the same thing as the table name. It's not compulsory to do it this way, but it just makes things neater and easier, and it's always the convention. Okay, so I created the table name called user, and it is created as a class. Now, when we use declarative mapping, this is just the syntax. You want to put the column name, a column, and we are mapping to what? The data type is int. So ID mapped, and then the pair of square bracket int is equal to, now we're using the mapped calling function, and we're going to be putting what it is mapped to. So the int that we know is mapped to integer for the ORM, and this is the reason we imported it here. So we are mapping, so when we use declarative mapping, in the parentheses of the mapped calling function or method, you specify the data type it is mapping to. Then you want to put the other constraints that we learned in MySQL. Primary key, we want this ID to be the primary key. We say primary key is equal to true. We also want it to auto increment, so we say auto increment equal to true. We put the next column we want to have, which is username. We want this to be varchar, which is a string. So a map string, str, is equal to, so you see how we are making this Python code, but now we are using classes to map this to what SQL, the object relational mapping is, and we specify the length. So if we're writing this in MySQL or in SQL, we'll know we'll put this as varchar 200, but this is a string. So map string, str is the data type in Python, and we'll map this to what it is with SQL Alchemy string, and that's why we imported it up here. And then we put the length we wanted. I wanted 200, and we want the username to be unique. So we say unique equal to true. Password, the same thing. We put this as map column. I want it to map column string, and we put the length 255. Now, when we create a table called user, we should see the ID, username, and password columns in that table. Now, I want to create another table called client's profile based on the forms. And what I want to do with this client's profile table is to put all of the demographic and personal information of a client in this table. So across all of the forms, we want to have the name mentioned once, the date of birth once, the country of birth, the gender, the marital status. Regardless of which form we are filling, we want to collect this information once and the profile and save this in something we call a client profile table. Now, when you look at the forms, the method of doing this is totally different. It mustn't be exactly how I did it. You have to think on your own and try to learn to do this in your own way by yourself. Your table names must not be the same. The way you want to group your tables or group data in different tables doesn't have to be the same. You only have to make sure that you keep the integrity of the data by using foreign keys and linking tables and not putting information in table more than once. And even if you want to put information in a table more than once, there is a way we use Python to control that information to go just once, and I'll show you that later on. So we want to create columns. So the first thing you put is all the column names, and then a column, and then mapped to the data type is mapping to in Python, and then use the map column function or method to provide what the SQL outcome is, what the ORM is. Int is integer, str is string, and datetime is datetime, like that. So when we want to put a default value, we use the same constraint names that we have in MySQL. Auto increment, primary key, default, unique. These are constraints that we always use. When we do foreign key in MySQL, we always have the on update cascade, on delete cascade. It's still the same thing. That will be like the keyword arguments here. So when you take a look at this, you see that we use created at to be a timestamp. We map to datetime data type, and then we provide what we are mapping to, this ORM, and we want the default time to be the current time, timestamp, so that if no time is entered, we want it to just timestamp the entry of the data at the current time where it is being saved. Updated at, we want it to do exactly the same thing, and then we want to do the created by. We want this created by to be a foreign key for the username. So if we can do this so that this particular will be done automatically by the system based on who is logged in, instead of us typing who enters. So there are a lot of automatic processes that will happen to extract the login user from the session and just automatically insert this person there. And now we're not typing in the name, it is a foreign key from the user table, knowing who is logged in. So we specify the table name that is the parent table and the column name that is the column that we're using as foreign key here. The same thing for the updated by. Now for the unique ID, we want it to be unique. You put the constraint here, and I think you get the point from here on. When you create columns, all of the columns are required by default until you use this optional. So when you want it to be optional, you want it to be a particular column where the user can choose to provide values or not. So maybe on the form, those are optional fields. The user can choose to enter a value or leave it without entering a value. So in a pair of square brackets, you write optional before you put the data type like this. So which means that it is going to mark that particular column as a column that allows null. If you don't put this, it means that that column is not null. Okay? So these are things that I want you to look through your lesson notes for week 25 for those of you in batch A, and for batch B, you can rewatch these videos until you get to week 25 to see exactly how these things are mapped. These are the standard way of doing it. So what you need to know is the syntax of writing this, and then you replace the column names with your own column names from the form or whatever project you are creating, and then you can read more on this to understand the syntax. So the same thing I did to want to create another table called the client screening STI to save all screening information. For syphilis, I did that again for the treatment, I did that again for the partner management. So I'm trying to create tables that groups related information together. So for the congenital syphilis, mother's table is different from the infant's table, and I created all of this table using the same syntax. So what you need to know is you create it as classes and you write your code this way. Once you are done with all of this, it is time to now come to the app file and then write base.metadata.create or engine. When we run this, the database exists, this connection string is correct. We should have tables created, all of the tables we specify created in the STI data database. So let's look at that it is created before we discuss the route. So I'll go to here, and I have created the database called STI data. We don't have any table in them, but I want to run this app file that has this code to create all the tables. I'll click on run, and if all is well, I should go back to my database and refresh. I should see that it now has tables, all of the tables I wanted, the user, the partner management, STI, the HEB, and all of these tables. And when I click on this and I look at this, I can see that we have all of these tables already created. We have the user table also. If I want to look at things like let's look at the design view. Let's see how it is related. We can now see which ones are foreign keys and the parent table and the child table for each. So we can see how all the tables are related, and we don't have to repeat information like this. So we can see that this user is a parent to everywhere that there is created by and updated by on all tables. So you can see this, the screen is rather small, so you won't be able to see the link clearly or what table links to what, but this. So for those of you who are like database administrator that you want to design a model for your back-end or front-end developers, or back-end developers majorly, this is what you do. Create a relationship, you plan the tables and column like this, and what is expected, and the relationship between all of the tables like this. Okay, so we have the model created successfully. So when you rewatch this video, you will understand that how we have created these models. The explanation is just basic. You just need to know that all of this has to be at the top, both your imports and all that, and you can import more things if you're using something different also, a different style, but this is basically it. This is the most basic form, and then you use declarative mapping like this. There are other ways to create your models without declarative mapping. You are free to research and learn that, but this is just okay for what we want to do. Okay, so now that this is completely created, we can go to the site. I'll copy this since we are running and see exactly what it looks like on the web page. So we have this. So this is the index page that was created, and the index page has, we use JavaScript. We don't need to know all of this. This is just for us to be able to work with the information. We have this that we can look at account settings, logout. From it, when we need to log out, we have home, about, so we can see the about page, overview page. How does this work is because we have routes here that we say when we come to the landing page home, render the template index.html, and the index.html holds all that information that you see there. Okay, when we have the about page, it renders about.html, and this holds all the information you see on the about page. So we use this render template function, and in the parentheses provide the HTML file that we want it to render or display when this route is when we get to this route. So the same thing with the overview, and now we have the home route. I just named it home, but what I want this to be is unsuccessful login by a user. We want the user to be redirected to a page, and that page is called home.html here, and this page uses all the expression, and we want it to pass the session and the username of the logged in person here into the form. And this is what we did here when we say username is equal to session username. So the session we imported here just holds that credentials for the logged in user. So I'm going to explain this one after the other. When I come to this page here, the first thing I want to look at is how to log in. Now on the login form, you see that here has /login. This is the URL that we use with the route decorator here, /login. So when anybody hits this endpoint, and the endpoint is /login, the site address /login, you want to see this login page. Now, the design I have created is to have register login, and we use for Awesome to put this there. So these are just basic. It's not a design course or a front-end course, so we're not looking at that. For those of you who have not taken course 1 and you decide that you want to learn front-end, registration is already open for front-end. Classes start September 16th if you're interested in doing that course, but this is just for back-end. So we look at the login and then register. So when someone comes here to log in and they don't have an account, they want to register on the system. Now, for production, this is not what will happen. The register form will not be exposed on the index page. The register form is something that an administrator who will have a default login will need to create an account for the users that will now log in. We will not. So if you want to allow self sign up, then you have a registration form on the landing page for anybody to access. If you want to have access control by an administrator, then they will create an account for people and they will receive an activation email for the account, and then they click on that email to activate, and then takes them to the site and they can now log in or set their password and log in. So there are different designs, different things you need to do. We're making it basic. We want the login and the register form to be on the same page, just using tabs. And then we also want to be able to create an account if the person doesn't have before logging in. Now, when we come here, we want to create this account. We want it to be saved in the user table or on the user table, and we'll have the ID, username, and password columns on this table. So what you can either do is to say you want to collect the information on the form, which is what we did here. So when I come to the login form here, on the login form, I'll explain this for you now. I have the navigation, and I put URL for login. So when we use URL for, now we use double curly brace to write, or when we want to write any Ginger expression here. So I use double curly brace, and I put URL for in the parentheses, specify the name of the function that holds that URL for login. Now see the URL for, the function name is login. It doesn't matter what it is. I can come here and change this to be logout. It doesn't matter. As long as my URL is for the function name, it is still going to run this function for that. So this is why a lot of people prefer to use URL for instead of writing the route, and then URL for will now make you to dynamically just use any URL without having to specify the URL, especially when we are passing variables to the URL, and these are dynamic things. And when you now begin to put fixed routes like / login / register, that will become more complex and problematic. So our href attributes, for those who did course 1, has the value in a pair of curly brace, and double curly brace. We want to specify the URL for helper function, and in the parentheses of that, specify the name of the function that holds the URL that we want to redirect to. So I did the same thing for this. The action attributes for the form should go to the login, should also go to the login function. Look at the URL for the login function. Now, we have put all of these as values of attributes for that form. The same thing we did for the register form. We did that, and we want this to be processed by the register route. So now we didn't use URL for, we use / register. And the reason I did this for you to see the dynamic nature of doing things. We can just use the / register here, which is the route here, or we can use URL for register if we want, like that. So if you use URL for, we are specifying the function name. If you're using route / what the decorator holds there. Do you guys understand?
Yes, please.
Okay. So on the app file now, we want to deal with login register. And we have the login form. Or let's just assume we have no login form. We created the model already, and we know that we want to collect username and password. The ID is already auto increment, and which means we don't need to provide value for the ID. I created a variable called MSG, which means message, and I've set it to an empty string. And the reason is we want to be able to send a message, and we want to store it in this variable when we have a message to display on the page. Maybe the login information is not correct, and things like that. Now, request holds the method get or post. And what we're doing here is to say, if the request method is post, if it's post, it means we are submitting the form. It is get, it means we are trying to display the form. So we just use this to make it easy using our conditional statement. If the request method is post, if the username is filled in and the password is filled in. So when we say request.form, the form is what is filled in. So when you're building only the back end without the front end, you don't actually need the front end. If you want to test this, you can actually test it by passing value to the function to see it works without having to deal with building the front end to test your back end. I just did this for those who want to build a monolithic system and have their templates and try to see how information flows. But normally, we just build functions and routes, and the front end people take over from there. Okay. So we look at if request method is post. So if the form is submitted, if the submit button is clicked, that form that holds that submit button that is clicked, if it has a form input with the name attribute value, username, and it has another one with password, we want to get those values from that input field that has the name attributes with the value of username and the one that has the value of password. So at this point, you are a front-end person. You are going to be using these names as the names of the values of the name attributes when you build your form. And when I come to the login here, you will see that my name attribute here has the value username, and this has the value password. So this is the importance of those who are currently in both front end and back end. Is the importance of your name attributes. The name you specify for your name attributes is the same name that this request is going to use to extract the value that the user has entered into this form. So when the user enters their username, this name attribute will take that as it saved something in this username, and it saved something in this password. If this name was user1, so it's going to be here is going to be not username, but it's going to be user1. So you understand what I'm trying to say. So it depends on the name. So whenever you are calling the values that the user has entered, you have to use the name of the value of the name attributes that the input field used to get the value entered into that input field. If you are using JavaScript, then you might want to use the ID. IDs are unique and it must be just for one field alone. Okay? So say if request method is post, that means if a submit button is clicked, the username field is filled in, the password is filled in. We want to get the values that are entered into the form. So we'll create a variable called username. Whatever name you want is a variable. We'll say it is equal to request.form. So request.form, and in a pair of square brackets, specify the value of the name attribute for that form field whose value you are trying to extract. I just use the .lower method here just to convert everything to lowercase later. Then again, I want to see the password that is entered. Now, password is sensitive, and I want to encrypt this. And this is the reason I imported hashname here. So I'll say the password entered is equal to request.form password. So you just use request.form in a pair of square brackets. You put in the value of the name attributes for each of the form fields. Store them in a variable. So if you have 100 form fields, you have 100 variables collecting the names of collecting the value of the name attribute for each of the field. Now, when you have done that, what do you do next? You want to see how to sanitize this input. You want to strip slashes, remove sensitive information, like anything that a hacker will use. You want to remove scripts and all that. There are functions to do that. I did not handle that there, but these are algorithms you want to write. The first thing you want to do, check if values are entered. You want to check if these values are required or optional. Check if all the required values are filled in. Check if they keep to any rules, if there are any. Extract these values into a variable. Then what do you want to do with the values you have extracted? Once you extract this value into a variable, you want to make sure that this is safe to go to the database. It's not going to go to the database and hack into the system. So you want to do things like strip slashes from, or maybe anything that makes it a script or an HTML code within the tag or JavaScript code that is going to hack into the database. If you want to make sure you look for functions that handle all of that, sanitize that input or sanitize that variable, then you come now to ask yourself, is there any sensitive information stored in these variables? Do you want to encrypt this information? How do you want to encrypt it? What do you want to do? So the first thing I want to do is I got the password that was entered, and I'm going to say, I'll hash the password, and I'm going to say password entered. All I want to use is the app secret key. So the secret key is sensitive. It's not supposed to be exposed. So I say the password, I'll add the secret key to the password, and then I will now use the hash lib dot. I use my encryption that I'm using is SHA-256. It's not the most secured, and encode. So this is what you just do basically to encrypt your password in its basic form. There are different ways. You can use AES encryption. I usually use AES for production. This is the basic method to do it. I need you to research on the different ways you can hash and encrypt what is more secured for depending on the data that you want to de-identify. And so now I have a password variable now, which now uses this method. So the way I've done this makes this now very difficult to hack because it has gone through different layers of obscuring this to encrypt it. And then there'll be a reverse method also that will change it back to plain text when we need to retrieve the information. So the first logic now you think of is that if I'm sending this data to the database with the password encrypted and it's not in plain text, when I'm retrieving it and I entered my information in plain text when I'm trying to log in, that means I have to decrypt that information I'm sending to the database to know that what is stored there is not the plain text. Check the password column of the database, take whatever information is there, decrypt it, and compare it with what I have entered to see if it is the same plain text, and then grant me access or deny access based on how correct it is. Now we said that we use Context Manager to manage resources and to avoid having to close a connection when we open. So here I said with engine.connect, connect is one of the methods that we are going to use to return a connection object. So we say with engine.connect has con, we want to do something. Now we want to check that username and password that the user has entered. Does it exist in the user table? So here we now put result is equal to, because we said has con here, so we're going to use con. You can say with engine.connect as connection or my connection, whatever name you use here, just an alias is what you continue using as your connection object. So say con.execute, I want to execute an SQL statement. I want to write through an SQL statement. I put them in a text method like this. And then I use the format string to just write this because I want to pass in the username and the password that the user entered that is stored in this. Okay? I say select all from user where username is equal to username and password is equal to password. And then I want to account is equal to results.fetch1. So run this query and fetch the result, commit that. Now it stores this in a variable called account. The result it gets, stores it in account. So if account is true, that means if it fetches a result, that means this username and password matches a credential in the user table, then get the session variable and set logged in to true, set the ID of the user of the session to be the ID of that results that is returned. You can do it in a different way, and then set the username of the session to be the username that was entered. Then this message, now we want to update this message variable to now hold a message that says logged in successfully, and then we want to redirect to the home page. So use URL for home. When it goes to the home page, we want it to send the message to that home page. And when we look at the URL for home here, it is going to URL for home here, it is the /home. And this renders a template home.html, and you see that the variable we passed in here, session.username, is passed into this. That will tell you the username of the person. It will say welcome the username on that page. So we pass this when we render the template. We pass the session username to that template. So that's what we have done here. That's just the short explanation of all of this. So the algorithm is check if a button is clicked, check if the form fields are filled, check if all required fields are filled, extract all of the values into a variable, sanitize the inputs, look for all of the types of security breach that can happen by when you collect inputs, and how you want to sanitize these inputs. Decide what you want to do with the data that has been sanitized now. If there's anyone you need to encrypt, what encryption method do you want to use? Do you want to check against the database if it already exists and you don't want to insert it anymore? Or if it exists and in the case of login, you want to say, yes, this exists, and then you want to log in the user. When you log in the user, where do you want to redirect the user to? What message do you want to display if the login failed? How do you want to define the session variables, the logged in ID, username that I did here? And then where do you want to redirect to when it's successful? Do you want to send a message to that template that you're redirecting to? What do you do if it is unsuccessful? You want to also update the message variable to hold this instead. And then if the request method is not post here, what we are doing is just to return the HTML form for login. So if the request method is get, the person clicks on the login route, give them the form. If the person clicks on the button, the request method will be post, process the form. So that's why I use the methods get and post here for one route. So you can use the login route, do a different method get, create another route for post, or you can just merge both of them together and use an if statement. If the method is post, process it. If the method is get, display the form. That's what happened here. Does everybody understand?
Yes.
Okay. Then also for register, we did exactly the same thing. All what I've just explained, collect information from the form, decide what you want to do. We have username, confirm username, check if both the username entered and the confirm username entered matches. If they don't match, display, return back the registration form, the register form, with a message saying that that particular column or the particular fields do not match. The same thing with the password. And then you connect to the database to check if that username already exists in the database, display a message if it already exists, and if it doesn't exist, insert the record into the database if it doesn't exist. And then at the end of the day, if the request method is get, display the form before we display it into the database. So when we are logging in here, all we did here for the login was to decrypt the password. It is in the register that we encrypt the password. Okay, so the encryption method used the password plus secret key, use the hash lib to encode, and then we use this, and then we encrypt it. When we are decrypting here, when we are logging in, we use the same method to decrypt what we encrypted. Okay, so you can read about the different types of encryption that we have, just for extra reading, for you to understand deeper what encryption is more secure and how to protect sensitive information before you send them to the database. Okay, so we use the same context manager, and then we use an insert query here to insert into user. So this is exactly what you learned in part 1, where you specify the column names and the values. These values will just insert the variable that holds whatever the user has entered into the field, and the password also to enter what the user has entered into the field. And then we'll redirect to if the account has been created successfully, we redirect to the login page with a message so that the user can log in. If the account is not created successfully, we do something else. And if the request method is get and not post, we just render the HTML form for the user to enter information. For logout, all we want to do is to delete all of the session information. So we use pop. And know we saw all of this in when we look at Python basics, we look at how to remove things. When we use the pop method, we remove pop because what we defined here was login. When we defined the session, when the person logs in, we defined logged in to be true ID, and we defined username. And now we just pop all those information out and redirect to the index page to say the person has logged out. So we deleted all session information. Okay, so let's go to the form. We're going to use the form to fill out this information to see if it works. So here we are trying to get information to the user table, and so I want to register the user because there's nobody to log in with. If I want to log in with anything now, let me log in with something, and I put any password. There's no information in the table, so it will give me the message incorrect username or password. So I want to register. Let's say my username is my email to make it unique, and I'll confirm username, and then I want to create a password for myself. And so let me say my password is, and I'll confirm password. So I can try that the password doesn't match and try to register, and to give me a message password don't match. Then I will try to register again to make sure that everything is correct. So you do the different layers of validation that you can think of before you send your data when all the validation has been passed. Okay, and that's why there is testing. So I'll put a password and I'll make sure they match this time, and then I'll click on register. So I just use the common password. So it redirects me to a login page where I can use the same credentials. Let's first go to the table, and we see that this has been inserted. My username is there and my password is encrypted, and it is there. Now, because of all the hacking that goes on, most of the time we won't encrypt the emails to anything that looks like sensitive information. We encrypt them, but this password has been encrypted, and so there is no way even the app developer will know the password of the user. So when you go to website, you visit website that you forget your password and you try to reset and they send you a temporary password, it is bad security. The system is supposed to generate a link for you to reset your password so that even the users at the other side, the site you're visiting, they have no idea about your password. They don't know your password. The only way you can know your password is for you to use the forgot password link that does things automatically without any human having knowledge of what it is. And so not even those who are the database administrator knows what your password is because it's encrypted. So if you forget your password, you use the reset button because they can't send you your password because they can't see it and they don't know it. Okay? Now I'll use the same information to log in. And when I click on login, it now redirects me to the login page here. So now what I did here is I sent the message using a GET request, logged in successfully to the URL. You can send this to any part of the page here as an expression. But it said, hi, my username here, and then welcome to this for me to start collecting information. When I come to my home base here, I have a common file that is going to be displayed on all of the page when a user successfully logs in. And then this file is inherited by the profile page. And this profile page is the place that we pass all of the information we want here. And here it says tab 1 update profile, and it gives you all this information. And the next tab gives us to enter other form information here. So if I come back here, I come back here, I can now begin to fill up all of this information, and then we'll look at the route that handles this, and then we'll see how we can retrieve the information for updates. I don't want to deal with this today because it will mean that we have to look through all of this code that has been written here in the app file. So does everybody understand?
That's very good.
Yeah.
Okay, so this is where we will end today's lesson. I want you to ask questions now if you have any, or I'll make sure the video is available within 48 hours so that you can watch and rewatch before the next class. But I'll make this available on GitHub for you to be able to clone only after the assignment for that week has been submitted, because it's just like copying this back for the assignment. Okay, so I want you to be able to watch this and be able to think out of the box, create your own route. You don't have to create an HTML form. You don't have to use you can just render templates if you want. You can do something else, but just create a function that is going to run when this route or this endpoint is gotten to by the user. So you can just create a print statement instead of return something and say print something. Or you can decide to do the Ginger template and learn how to build this. It's not a front-end course, so I'm not imposing that you create HTML files for whatever you do. So it's up to you to decide. Okay? So in the absence of questions, thank you all and see you all next week.
Thank you.
Thank you.
All right, bye.
Bye.